What if the universe had secrets so bizarre they could change the way you see everything? Picture this: stars that refuse to die, planets made of diamond, and a void so vast it defies imagination. In this video, we're diving into 30 of the most mind-bending galactic facts that will leave you questioning reality itself. From the eerie pull of the Great Attractor to the chilling cold of the Boomerang Nebula, these cosmic wonders are more incredible than science fiction. Buckle up, because by the end of this journey, you'll have a whole new appreciation for the strange and spectacular mysteries of space, ready to explore the unknown. Let's get started. Now, let's dive into our first galactic marvel, the Great Attractor. Imagine a force so powerful that it's pulling entire galaxies toward it, including our own Milky Way. This mysterious gravitational anomaly, known as the Great Attractor, lies about 250 million light-years away from Earth. It's located in a region of space called the Zone of Avoidance, an area obscured by the dense disk of our own galaxy. This makes it incredibly difficult to observe directly, as the light from the Great Attractor is blocked by stars, gas, and dust. Scientists believe it could be a massive concentration of matter, possibly a supercluster of galaxies, exerting its gravitational influence across the cosmos. Yet, its true nature remains one of the universe's most tantalizing mysteries. What could be lurking in this unseen corner of space? The search for answers continues, pulling us deeper into the enigma of the Great Attractor. Shifting our gaze to another cosmic enigma, let's explore the eerie world of zombie stars. These celestial revenants, known as white dwarfs, have a dark and fascinating secret: they can come back to life. Picture a dense, burned-out star, no longer capable of nuclear fusion, lurking in the shadows of space. But when a white dwarf orbits a companion star, it can pull material from its partner, slowly siphoning off gas and dust. Over time, this stolen matter accumulates on the white dwarf's surface, reigniting a thermonuclear explosion, a supernova. What's even more astonishing is that this process can repeat itself, with the white dwarf repeatedly dying and reawakening in a cycle of stellar destruction. These repeated supernovae, known as Type 1a, are so powerful they outshine entire galaxies. The idea of a star cheating death over and over is as haunting as it is mesmerizing, offering a glimpse into the strange and violent afterlife of stars. This eerie phenomenon reminds us that even in the vastness of space, the dead can rise again. Now, let's journey to a world that shimmers with unimaginable beauty: diamond planets. Picture a planet not made of rock or gas, but of sparkling diamond. One such celestial gem is 55 Cancri, a planet located about 40 light-years from Earth. This exotic world is thought to be composed largely of carbon, which, under immense pressure, crystallizes into diamond. Imagine a surface glittering with diamond mountains and vast plains of precious gemstone. But how does such a planet form? In carbon-rich star systems where carbon outweighs oxygen, planets can develop with an abundance of this element. When extreme heat and pressure are applied, like those found deep within a planet's core, carbon transforms into diamond. 55 Cancri orbits so close to its star that its surface temperatures reach scorching levels, making it a fiery, glittering marvel. These diamond worlds remind us that the universe is full of treasures beyond imagination, offering a glimpse into the extraordinary diversity of planetary formation. Who knew that some of the most dazzling jewels in existence might be light-years away, hidden among the stars? Now, let's shift our focus to a place that defies our understanding of cold: the Boomerang Nebula. This cosmic wonder holds the title of the coldest known place in the universe, with temperatures plummeting to just 1 degree above absolute zero. To put that into perspective, even the vast emptiness of space, which averages around -454 degrees Fahrenheit, feels warm compared to this icy realm. So, how does the Boomerang Nebula achieve such extreme cold? The answer lies in its unique structure. This nebula is actually a dying star, expelling gas at an astonishing speed of over 300,000 miles per hour. As the gas rapidly expands, it cools down dramatically, creating this frigid environment. Adding to its mystery, the Boomerang Nebula's distinctive bow tie shape, captured in stunning images, is a result of this high-speed outflow interacting with surrounding cosmic material. This celestial phenomenon not only challenges our perception of cold, but also offers a glimpse into the dramatic final stages of a star's life. Who would have thought that the coldest spot in the universe could be found in the depths of space, shaped by the forces of stellar death and expansion? Now, let's venture into the realm of rogue planets, those solitary wanderers of the cosmos. Unlike the planets we're familiar with, these mysterious objects don't orbit a star but instead drift freely through the vast expanse of space. Imagine a world untethered from any solar system, floating in perpetual darkness. Scientists believe rogue planets can form in two main ways. Some are born from collapsing clouds of gas and dust, much like stars, but without enough mass to ignite and become one. Others are ejected from their home systems due to gravitational interactions, sent hurtling into the void. Despite their isolation, these planets might not be completely lifeless. Some could retain enough internal heat to support liquid water beneath thick, icy surfaces, raising the tantalizing possibility of microbial life. While they may lack the warmth of a sun, rogue planets remind us that the universe is full of unexpected places where life might find a way to endure. These celestial nomads challenge our understanding of planetary systems and open up new questions about where life could exist in the cosmos. Now, let's turn our gaze toward one of the most breathtaking sights in the cosmos, the Pillars of Creation. Nestled within the Eagle Nebula, these towering columns of gas and dust have become an iconic symbol of the universe's beauty and complexity. Captured by the Hubble Space Telescope, the image reveals a stellar nursery where new stars are born. The pillars are dense regions of gas and dust acting as cosmic incubators. Inside them, gravitational forces pull material together, causing it to collapse and ignite, giving birth to young stars. But this serene process is not without its challenges. Over time, intense radiation and cosmic winds from nearby stars have been slowly eroding these majestic structures. Despite their gradual destruction, the pillars of creation continue to inspire wonder, offering us a glimpse into the dynamic and ever-changing nature of the universe. They remind us that even in the vastness of space, creation and destruction are intimately intertwined, shaping the cosmos in ways we are only beginning to understand. Now, let's shift our focus to one of the universe's most astonishing cosmic phenomena, hypervelocity stars. These are stars that travel at mind-boggling speeds, often moving so fast they can escape the gravitational pull of their home galaxies. Imagine a star being flung across the cosmos at millions of kilometers per hour, like a cosmic bullet racing through the void. How do stars reach such incredible velocities? The answer lies in the extreme forces of nature. One common scenario involves supermassive black holes at the centers of galaxies. When a binary star system ventures too close to a black hole, one star can be captured while the other is slingshotted away at extraordinary speeds. Another possibility is the explosive power of supernova. When a star explodes, it can propel its companion star outward with such force that it becomes a hypervelocity star. These stellar speedsters offer scientists a unique way to study the dynamics of galaxies and the powerful forces that shape them. While they may seem like cosmic outliers, hypervelocity stars remind us of the sheer energy and unpredictability that define our universe. Now, let's turn our attention to a fascinating aspect of our own cosmic neighborhood, the Milky Way's cannibalistic past. Believe it or not, our galaxy didn't always look the way it does today. Over billions of years, the Milky Way has grown by consuming smaller galaxies in a process known as galactic cannibalism. This might sound like something out of a science fiction story, but it's a reality supported by compelling evidence. One of the clearest signs of this cosmic feast lies in stellar streams, long trails of stars that stretch across our galaxy. These streams are the remnants of smaller galaxies torn apart by the Milky Way's immense gravitational pull. Another piece of evidence comes from ancient star clusters, some of which have chemical compositions that differ from the Milky Way's native stars. These clusters are thought to be the surviving cores of galaxies that were absorbed long ago. By studying these clues, astronomers have pieced together a history of the Milky Way as a cosmic predator, continuously growing by devouring its smaller neighbors. This cannibalistic behavior isn't unique to our galaxy. It's a common process in the universe, one that has shaped the galaxies we see today. So, the next time you gaze at the night sky, remember that the Milky Way's beauty is partly the result of its voracious appetite for smaller galaxies. Now let's delve into a cosmic puzzle that has astronomers scratching their heads, the Hubble Constant controversy. This all revolves around the universe's expansion rate, and here's the twist: scientists can't seem to agree on how fast it's actually happening. The Hubble Constant is a number that represents how quickly the universe is stretching out over time. But here's where things get interesting. When scientists measure this rate using nearby galaxies and supernova, they get one number. When they use the cosmic microwave background, the afterglow of the Big Bang, they get a different number. This discrepancy has sparked ongoing debates in the world of cosmology, as both methods are well established and yet produce conflicting results. Some researchers suggest new physics might be at play, like unknown forms of dark energy or even undiscovered particles. Others think there might be errors in the measurements or our understanding of the tools we use. Whatever the case, this controversy has far-reaching implications. If the universe's expansion rate is faster or slower than we thought, it could change our understanding of the cosmos's age, its fate, and even the nature of dark energy. For now, the Hubble Constant remains one of the most intriguing mysteries in modern astronomy, reminding us that the universe still has plenty of secrets left to uncover. Moving on to another cosmic enigma, let's explore the Eridanus supervoid, a colossal empty region in space that stretches over 1 billion light-years across. This vast void is not just a simple empty space, but one of the largest known structures in the universe. Unlike most regions of space, which are dotted with galaxies, stars, and cosmic dust, the Eridanus supervoid is eerily barren. Scientists believe it formed as a result of the universe's large-scale structure, where matter clumps together in some areas while leaving others nearly empty. But what makes this void even more fascinating is its impact on the cosmic microwave background radiation, the faint glow left over from the Big Bang. Researchers have observed a cold spot in this radiation that aligns with the location of the supervoid. One theory suggests that the void's emptiness allows light traveling through it to lose energy, creating this cold spot. However, the sheer size of the void challenges our current understanding of cosmology, as such massive empty regions shouldn't exist according to the standard model of the universe. Some scientists propose alternative explanations, like the presence of exotic dark energy or even a collision with another universe. The Eridanus supervoid remains a captivating mystery, offering a glimpse into the complex and often counterintuitive nature of the cosmos. Now let's venture into one of the most perplexing mysteries of the cosmos, the black hole information paradox. At its core, this paradox revolves around a fundamental question: what happens to information when it's swallowed by a black hole? According to classical physics, once something crosses a black hole's event horizon, it's gone forever, lost to the universe. But this idea clashes with the principles of quantum mechanics, which state that information can never be truly destroyed. So, where does the information go? This puzzle has baffled scientists for decades, and even the legendary physicist Stephen Hawking contributed to the debate. Hawking proposed that black holes emit radiation, now known as Hawking radiation, which causes them to slowly lose mass and eventually evaporate. But here's the twist: this radiation seems to carry no information about what the black hole consumed. This leads to the paradox: if the black hole disappears and the radiation contains no information, where did all that information go? Some theories suggest that the information isn't lost but is instead encoded in the Hawking radiation in ways we don't yet understand. Others propose that it might be stored on the black hole's event horizon or even in a hidden layer of reality. The black hole information paradox remains one of the most hotly debated topics in physics, challenging our understanding of the universe at its deepest levels. It's a reminder that even the most mysterious objects in space still hold secrets waiting to be unraveled. Now, let's take a mesmerizing turn to witness a cosmic dance that's been unfolding for millions of years. Enter Messier 51b, the Whirlpool Galaxy's smaller companion, locked in a gravitational embrace that's shaping both galaxies in extraordinary ways. Located roughly 23 million light-years from Earth, the Whirlpool Galaxy, also known as Messier 51a, is a stunning spiral galaxy that's often admired for its intricate, swirling arms. But what makes it even more fascinating is its interaction with Messier 51b, a dwarf galaxy that's been drawn into its gravitational pull. As these two galaxies orbit each other, their mutual attraction creates tidal forces that distort their shapes and trigger bursts of star formation. The Whirlpool Galaxy's spiral arms, for instance, are stretched and twisted by the gravitational tug from its companion. Meanwhile, Messier 51b isn't just a passive partner. Its own structure is being warped by the whirlpool's immense gravity, and it's losing gas and dust in the process, which feeds the whirlpool's star-forming regions. This dynamic interaction between the two galaxies is a vivid reminder of how interconnected the cosmos truly is. Scientists believe that this gravitational dance will continue for billions of years, eventually leading to the merging of the two galaxies into a single, larger structure. For now, though, their celestial waltz offers a breathtaking glimpse into the ever-changing nature of our universe, where even galaxies are never truly alone. Shifting our gaze to the realm of extreme cosmic phenomena, let's turn our attention to VFTS 102, a star that spins at such an astonishing speed it's on the verge of ripping itself apart. Located in the Tarantula Nebula, part of the Large Magellanic Cloud, VFTS 102 is a runaway star hurtling through space at a staggering velocity while rotating at a mind-blowing pace. To put it into perspective, this star completes a full rotation in just 24 hours, compared to our Sun's leisurely 25-day spin. But what causes a star to spin so fast? Scientists believe VFTS 102's extreme rotation might be the result of a dramatic past. One theory suggests it was once part of a binary star system, where its companion exploded in a supernova, sending VFTS 102 spinning out of control like a cosmic top. Another possibility is that it absorbed material from its companion before the explosion, increasing its mass and rotation rate. This rapid spin has dramatic effects on the star's shape. Instead of being a perfect sphere, VFTS 102 is flattened at its poles and bulging at its equator, due to the immense centrifugal force pushing its outer layers outward. In fact, it's spinning so fast that it's nearly at the breaking point, with its outer layers barely held together by gravity. If it were spinning just a bit faster, the star would literally tear itself apart. VFTS 102 is a fascinating example of how extreme conditions can push celestial objects to their limits, offering us a glimpse into the dynamic and often violent nature of the universe. Now, let's venture into the fascinating complexity of triple star systems, where not one, not two, but three stars dance around each other in a delicate celestial ballet. One of the most well-known examples is Alpha Centauri, a system located just over 4 light-years away from Earth. Here, three stars Alpha Centauri A, Alpha Centauri B, and Proxima Centauri are locked in an intricate gravitational embrace. Alpha Centauri A and B form a close binary pair, orbiting each other every 80 years, while Proxima Centauri, the smallest and faintest of the three, orbits this pair at a much greater distance, taking hundreds of thousands of years to complete its journey. The gravitational dynamics in such systems are incredibly complex. Each star exerts a pull on the others, creating a constantly shifting balance of forces. In a triple star system, the gravitational interactions can lead to chaotic but stable orbits, with each star influencing the path of the others in ways that are difficult to predict. These systems can also experience periods of instability, where one star might be ejected from the group entirely, leaving behind a binary pair. What makes triple star systems so intriguing is their potential to host planets. While the gravitational tug-of-war makes planetary orbits more complicated, scientists have discovered planets in some of these systems. For example, Proxima Centauri is known to have at least one planet, Proxima Centauri b, which orbits within its habitable zone. The existence of such planets raises questions about how life might develop in these dynamic environments. Triple star systems are a testament to the diversity and complexity of the cosmos, reminding us that even the most familiar celestial objects can hold surprising secrets. Moving from the dynamic interplay of triple star systems, let's now uncover a haunting cosmic mystery, the ghostly light of zombie galaxies. These are galaxies that, despite having ceased their star-forming activity long ago, continue to emit a faint, eerie glow. This lingering light, often referred to as starlight from beyond the grave, originates from stars that were born billions of years before the galaxy's star formation stopped. These aging stars, mostly red giants and white dwarfs, still shine faintly, even though no new stars are being created. The absence of young, bright stars gives these galaxies a dim, ghostly appearance, as if they are the spectral remnants of a once thriving cosmic civilization. But what causes a galaxy to stop forming stars in the first place? Scientists believe that internal processes, such as the depletion of gas needed to form new stars, or external factors, like interactions with other galaxies or the surrounding cosmic environment, can effectively kill a galaxy's star-forming potential. Some zombie galaxies may have been stripped of their gas by nearby galaxy clusters, leaving them with nothing to fuel new star birth. Others might have consumed all their available gas in a burst of intense star formation, leaving behind only the fading embers of their past glory. Interestingly, this ghostly light can persist for billions of years, offering astronomers a glimpse into the final stages of galactic evolution. By studying these zombie galaxies, scientists can better understand how galaxies evolve over time and what factors lead to their eventual death. These cosmic remnants serve as a reminder that even in the vastness of the universe, nothing lasts forever, not even the brightest of galaxies. Now, let's turn our attention to one of the most puzzling questions in the cosmos, the Fermi Paradox. Given the sheer size of the universe, with its hundreds of billions of galaxies and countless stars, it seems almost certain that intelligent life must exist elsewhere. Yet, despite our best efforts, we've found no definitive evidence of extraterrestrial civilizations. This contradiction is at the heart of the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everyone?" The paradox highlights the strange silence of the universe despite its apparent potential for life. To understand why we haven't made contact, scientists have proposed several possible solutions. One of the most intriguing is the idea of the Great Filter, a hypothetical barrier that prevents life from reaching an advanced stage. This filter could occur at any point in the development of life, from the emergence of simple organisms to the rise of technological civilizations. If the Great Filter lies in our past, it means we've already overcome a rare and difficult hurdle, which would explain why we don't see other advanced civilizations. But if the Great Filter lies in our future, it suggests that civilizations like ours are doomed to collapse before they can explore the stars. Other explanations for the Fermi Paradox include the possibility that intelligent life is simply too rare, or that advanced civilizations avoid detection by design. Some theories propose that interstellar communication is far more difficult than we imagine, or that extraterrestrial life exists in forms we can't recognize. Whatever the reason, the Fermi Paradox challenges our assumptions about life in the universe and reminds us of how much we still have to learn. It's a mystery that continues to inspire both curiosity and caution as we search for answers among the stars. Now, shifting our focus to the vastness of cosmic structures, let's explore the Hercules-Corona Borealis Great Wall, the largest known structure in the universe. This colossal formation stretches an astonishing 10 billion light-years across, making it a true giant even on the scale of the cosmos. To put that into perspective, it's so immense that it challenges our understanding of how such structures can form. The Great Galactic Wall is a massive filament of galaxies, galaxy clusters, and dark matter woven together in a complex web. Its discovery in 2013 stunned astronomers, as it defies the principles of cosmology that suggest such enormous structures shouldn't exist. According to the cosmological principle, the universe should appear roughly the same in all directions on a large scale. But the Great Wall's sheer size and scale seem to contradict this idea, raising questions about our models of the universe's evolution. Some scientists speculate that it could be a remnant of fluctuations in the early universe, while others suggest it might be a rare statistical anomaly. The existence of this structure forces us to reconsider our understanding of cosmic expansion, dark matter distribution, and the limits of how large structures can grow. It's a reminder that even with all we've learned, the universe continues to surprise us with its mysteries. As we piece together the story of the cosmos, the Great Galactic Wall stands as a humbling testament to the vastness and complexity of the universe. Moving from the grand scales of cosmic structures to something a bit closer to home, let's dive into an intriguing phenomenon that's been shaping our planet for billions of years: the moon's wobble. You might think of the moon as a steady companion, always there in the night sky, but its orbit isn't as fixed as it seems. Over time, the moon experiences what's called a wobble, a gradual shift in its path around Earth. This wobble, which occurs in an 18.6-year cycle, might sound minor, but it has a surprisingly significant impact on something we experience daily: our tides. As the moon's orbit changes, the gravitational pull it exerts on Earth's oceans shifts slightly, leading to periods of higher high tides and lower low tides. While these changes are subtle, they can add up over time, especially in coastal areas. Scientists predict that during the wobble's amplification phase, which we're currently entering, the combination of higher tides and rising sea levels due to climate change could lead to more frequent and severe coastal flooding. This means cities and communities near the coast could face greater challenges in the coming decades. Understanding the moon's wobble isn't just about astronomy, it's about preparing for its real-world effects here on Earth. This phenomenon reminds us that even the smallest shifts in the cosmos can have a profound impact on our lives. Shifting our gaze from the moon's subtle influence, let's unravel another cosmic mystery that has puzzled scientists for decades: the Missing Baryon Problem. You might think that the universe is vast and filled with everything we can imagine, but here's the twist. A significant portion of the ordinary matter, the stuff that makes up stars, planets, and even us, seems to be missing. When scientists calculate the total amount of ordinary matter, or baryons, that should exist based on the early universe's conditions, they find a discrepancy. About half of it is unaccounted for. This isn't dark matter we're talking about. This is the visible, tangible matter that should be right there in our observations. So where is it hiding? The leading theory suggests that this missing matter exists as hot, diffuse gas in the vast spaces between galaxies, known as the intergalactic medium. This gas is so thin and spread out that it's incredibly difficult to detect with traditional telescopes. However, advanced instruments and techniques, like those used in X-ray astronomy, have started to reveal faint traces of this elusive material. Another possibility is that some of the missing baryons are tied up in cosmic filaments, the web-like structures that connect galaxies across the universe. These filaments, made of gas and dust, are thought to channel matter between galaxies, but their faint glow makes them hard to observe directly. Solving the missing baryon problem isn't just about finding where the matter is, it's about understanding the universe's structure and how it evolved over billions of years. It's a reminder that even the most basic questions about the cosmos still hold surprises waiting to be uncovered. Now, let's turn our attention to an event that will redefine the cosmos as we know it, the future collision between the Milky Way and the Andromeda Galaxy. Picture this: two massive galaxies, each containing hundreds of billions of stars, hurtling toward each other at a staggering speed of around 250,000 miles per hour. But don't worry, this cosmic dance won't happen anytime soon. We're talking about 4.5 billion years from now, plenty of time for Earth to go through its own changes. So, what exactly will happen when these two galactic giants meet? Surprisingly, it won't be as destructive as it sounds. The vast distances between stars mean that direct collisions between them are incredibly rare. Instead, the two galaxies will pass through each other, their gravitational forces pulling and twisting their shapes into a chaotic but beautiful dance. Over time, they'll merge into a single, even larger galaxy, often referred to as Milkomda. During this merger, stars and planets will be flung into new orbits, but the likelihood of any solar system being destroyed is extremely low. As for the night sky, it will transform dramatically. The stars we see today will be scattered, replaced by a dazzling array of new ones from Andromeda. Eventually, the two galaxies' supermassive black holes will also merge, releasing an immense amount of energy in the form of gravitational waves. This collision isn't just a random event, it's a natural part of how galaxies evolve and grow over billions of years. So, while the idea of our galaxy colliding with another might seem apocalyptic, it's actually a testament to the dynamic and ever-changing nature of the universe. Shifting our gaze to the very fabric of the universe, let's explore the cosmic microwave background, often described as the afterglow of the Big Bang. This faint radiation fills the cosmos, serving as a cosmic time capsule from when the universe was just 380,000 years old. Imagine it as a baby picture of the universe, capturing its earliest moments after the explosive birth of everything we know. The cosmic microwave background was discovered by accident in the 1960s, when scientists detected a persistent hum of microwave radiation coming from all directions in space. This discovery provided overwhelming evidence for the Big Bang theory, as it matched predictions made decades earlier. What makes this radiation so special is its uniformity. It's almost the same everywhere we look, with tiny fluctuations that reveal the seeds of future galaxies and galaxy clusters. These minuscule ripples are like cosmic fingerprints, showing how matter was distributed in the early universe. By studying these patterns, scientists have been able to piece together the universe's composition, including the amounts of dark matter and dark energy. The cosmic microwave background also helps us understand the universe's geometry, confirming that it's flat on a large scale. This was a groundbreaking revelation that reshaped our understanding of cosmology. But it doesn't stop there. This ancient light continues to reveal new secrets, offering insights into the universe's age, its expansion rate, and even the number of neutrino species. It's like a treasure trove of information hidden in the faintest glow of microwaves. So, the next time you hear static on an old television, remember that a tiny fraction of that noise is actually the universe's oldest light whispering the story of its birth. Now, let's turn our attention to one of the most colossal objects in the cosmos, Scuti, the largest known star in the universe. This hypergiant star is so massive that if it were placed at the center of our solar system, its outer layers would stretch beyond the orbit of Jupiter, engulfing everything in its path. To put its sheer size into perspective, Scute's radius is estimated to be around 1,700 times that of our Sun. That means if the Sun were the size of a golf ball, Scute would be as large as a professional basketball stadium. But size isn't the only thing that makes this star extraordinary. Scute is also incredibly luminous, shining with a brilliance that dwarfs even the brightest stars in our galaxy. Despite its enormous size, Scute is relatively young in cosmic terms, and its lifespan is expected to be short compared to smaller stars like our Sun. This is because hypergiants burn through their fuel at an astonishing rate, leading to a dramatic and explosive end as a supernova. Interestingly, Scute's exact size is still a topic of debate among astronomers, as its immense distance and the surrounding cloud of gas and dust make precise measurements challenging. Still, one thing is certain: this star is a testament to the mind-boggling scale of the universe. So the next time you look up at the night sky, remember that somewhere out there, Scute looms as a true giant, reminding us just how vast and awe-inspiring the cosmos truly is. Now, let's shift our focus to one of the most profound mysteries in modern cosmology: dark energy. This enigmatic force is believed to be the driving factor behind the accelerating expansion of the universe. Unlike gravity, which pulls objects together, dark energy seems to work in the opposite direction, pushing galaxies apart at an ever-increasing rate. Its existence was first hinted at in the late 1990s, when astronomers observed that distant supernovae were dimmer than expected, suggesting the universe's expansion was speeding up rather than slowing down. Since then, dark energy has become a cornerstone of our understanding of the cosmos, accounting for roughly 68% of the universe's total energy content. But what exactly is dark energy? That's the million-dollar question. Some scientists propose it's a property of space itself, often referred to as the cosmological constant, an idea first introduced by Albert Einstein. Others suggest it could be a dynamic field, like the Higgs field, that permeates the universe. There's even the possibility that our current understanding of gravity is incomplete, and dark energy is a sign that we need to rethink the laws of physics. To unravel this mystery, researchers are conducting experiments like the Dark Energy Survey and the upcoming Euclid mission, which aim to map the universe's large-scale structure and measure its expansion with unprecedented precision. Despite these efforts, dark energy remains elusive, its true nature hidden from our view. What we do know is that it holds the key to understanding the ultimate fate of the universe. Will the expansion continue forever, leading to a cold, empty cosmos, or will dark energy's behavior change, altering the universe's destiny? These are questions that keep astronomers awake at night, and the answers may lie in the shadows of the cosmos. Now, let's venture into the realm of neutron stars, where density reaches levels that seem almost impossible to imagine. These incredible remnants of massive stars are so compact that a piece the size of a sugar cube would weigh billions of tons. To put that into perspective, if you could somehow scoop up a tiny fragment of a neutron star, it would outweigh entire mountains on Earth. This mind-boggling density comes from the aftermath of a supernova explosion. When a massive star exhausts its fuel, it collapses under its own gravity, crushing its core into a neutron star. In this process, protons and electrons are squeezed together to form neutrons, packing an immense amount of mass into a sphere no larger than a city. But the strangeness doesn't stop there. Neutron stars also boast some of the most extreme conditions in the universe. Their surfaces are millions of degrees hot, and their magnetic fields are trillions of times stronger than Earth. Some even spin hundreds of times per second, emitting beams of radiation that we detect as pulsars. These exotic properties make neutron stars not only fascinating but also invaluable laboratories for testing the laws of physics under conditions we could never replicate on Earth. From their formation in the fiery deaths of stars to their role in shaping the cosmos, neutron stars remind us just how bizarre and awe-inspiring the universe can be. Moving further into the outer reaches of our solar system, we encounter the mysterious Oort cloud. This vast spherical shell of icy objects lies far beyond the orbit of Pluto, stretching halfway to the nearest star. Imagine a cosmic reservoir holding trillions of icy bodies, some as small as pebbles and others as large as mountains. The Oort cloud is so distant that it takes light from the sun over a year just to reach its inner edge. But what makes this region truly fascinating is its role as the birthplace of long-period comets. These comets, which can take thousands or even millions of years to complete a single orbit, originate from the Oort cloud. When gravitational disturbances like passing stars or the pull of the Milky Way nudge these icy bodies out of their stable orbits, they begin a long journey toward the sun. As they approach, the heat causes the ice to vaporize, creating the stunning tails we associate with comets. Scientists believe the Oort cloud is a relic from the early solar system, a frozen archive of the building blocks that formed our planets. Studying these icy visitors offers us a glimpse into the conditions that existed over 4.5 billion years ago, when the Sun and its family of planets were just beginning to take shape. The Oort cloud, though hidden and remote, plays a crucial role in shaping the dynamic nature of our solar system, reminding us that even the farthest corners of space hold secrets waiting to be uncovered. Now, let's shift our gaze to a concept that stretches the boundaries of imagination, the multiverse theory. This idea suggests that our universe might not be the only one out there. Instead, there could be countless other universes, each with its own set of physical laws, dimensions, and even versions of you. The multiverse theory isn't just science fiction. It's rooted in some of the most advanced areas of physics, like quantum mechanics and string theory. For instance, when scientists study the behavior of particles on the smallest scales, they encounter phenomena that hint at the existence of parallel realities. One of the most compelling pieces of evidence comes from the cosmic microwave background, the faint glow left over from the Big Bang. Some researchers believe that unusual patterns in this radiation could be bruises caused by collisions between our universe and neighboring ones. Beyond the science, the multiverse theory raises profound philosophical questions. If there are infinite universes, does every possible outcome exist somewhere? Could there be a universe where history unfolded completely differently? While we can't yet prove the existence of other universes, the multiverse theory challenges us to think bigger, reminding us that the cosmos might be far more complex and wondrous than we ever imagined. Now, let's turn our attention to a mystery that has puzzled scientists and dreamers alike, what's known as the Great Silence. Imagine scanning the vast expanse of the universe, listening intently for any sign of intelligent life, only to be met with nothing. This eerie absence of signals from extraterrestrial civilizations is one of the most perplexing questions in astronomy. With billions of galaxies, each containing countless stars and planets, why haven't we detected even a single whisper from another civilization? One of the leading explanations is the rare Earth hypothesis, which suggests that the conditions necessary for complex life might be extraordinarily rare. Even if planets with water and atmospheres are common, the precise combination of factors needed, like a stable star, a protective magnetic field, and just the right distance from a star, could be vanishingly uncommon. Other theories propose that advanced civilizations might be using communication methods we haven't discovered yet, or perhaps they're deliberately avoiding contact. Some even speculate that intelligent life might self-destruct before it can reach the stars, a sobering thought known as the Great Filter. Whatever the reason, the Great Silence reminds us just how mysterious and isolating the cosmos can be, leaving us to wonder if we're truly alone, or if the universe is simply waiting for the right moment to speak. Shifting our gaze to another cosmic marvel, let's explore Hoag's object, a galaxy unlike any other. Imagine a perfect ring of stars glowing brightly against the dark void of space with a serene, spherical core at its center. This striking structure, known as Hoag's object, is a rare example of a ring galaxy. What makes it even more fascinating is how it defies the typical spiral or elliptical shapes we associate with galaxies. Scientists believe that such ring galaxies might form through galactic collisions, where a smaller galaxy passes through the center of a larger one, triggering shockwaves that push stars outward into a ring. Another theory suggests that a central bar of stars might have once existed, but over time it dispersed, leaving behind this luminous halo. Hoag's object not only challenges our understanding of galaxy formation, but also serves as a reminder of the universe's endless capacity for creating beauty in the most unexpected ways. This celestial oddity invites us to ponder just how diverse and mysterious the cosmos truly is. Now, let's turn our attention to one of the most astonishing powerhouses in the universe, quasars. These celestial objects shine with a brilliance that outshines entire galaxies, making them the brightest entities we've ever observed. At their core lies a supermassive black hole, consuming vast amounts of matter at an incredible rate. As this material spirals into the black hole, it heats up to extreme temperatures, releasing an immense amount of energy in the form of light and radiation. This process is what makes quasars visible across billions of light years. But quasars aren't just dazzling to look at, they play a crucial role in shaping the galaxies they inhabit. The intense energy they emit can influence star formation, sometimes triggering it in surrounding regions or, conversely, halting it by blowing away the gas and dust needed to create new stars. Quasars also provide us with a unique window into the early universe, as many of them formed billions of years ago when galaxies were still in their infancy. By studying these luminous beacons, scientists can piece together the story of how galaxies evolved over time. The sheer scale of a quasar's energy output is almost beyond comprehension, reminding us once again of the awe-inspiring forces at work in the cosmos. Now, as we near the end of our cosmic journey, let's peer into the distant future and ponder the ultimate fate of the universe. Scientists have proposed several fascinating scenarios, each painting a unique picture of how everything we know might one day come to an end. One such possibility is the Big Freeze, also known as the heat death of the universe. In this scenario, the universe continues expanding indefinitely, spreading matter and energy so thin that stars can no longer form. Over trillions of years, galaxies will fade, and the universe will grow colder and darker until it reaches a state of total stillness. Another theory is the Big Rip, a more dramatic end where the universe's expansion accelerates so rapidly that it tears apart galaxies, stars, planets, and even atoms themselves. This would result in a universe where nothing can hold together, leaving only isolated particles drifting in emptiness. These theories hinge on the behavior of dark energy, the mysterious force driving the universe's expansion. If dark energy grows stronger over time, it could lead to the Big Rip, whereas if it remains constant, the Big Freeze becomes more likely. While these scenarios sound bleak, they remind us of the incredible complexity and dynamism of the cosmos. Understanding the universe's ultimate fate isn't just about predicting doom. It's about unraveling the fundamental laws that govern everything around us. As we wrap up our exploration of these 30 bizarre galactic facts, let's take a moment to marvel at the vastness and mystery of the universe we call home. And so, we've journeyed through 30 of the most bizarre and mind-bending facts about our universe, each one a reminder of how vast, strange, and awe-inspiring the cosmos truly is. From the mysterious pull of the Great Attractor to the eerie glow of zombie galaxies, from the glittering diamond planets to the chilling emptiness of the Boomerang Nebula, each discovery pushes the boundaries of our understanding and fuels our curiosity. These facts aren't just fascinating, they're invitations to keep exploring, to keep questioning, and to marvel at the wonders that lie beyond our tiny corner of the universe. So, which fact left you the most amazed? Was it the mind-boggling size of Uy-Scuti, the haunting silence of the Fermi Paradox, or the cosmic dance of the Whirlpool Galaxy? Let us know in the comments below. We'd love to hear your thoughts. And if you enjoyed this journey through the cosmos, don't forget to hit that subscribe button and ring the notification bell so you never miss out on our next adventure into the mysteries of space. Stay curious, keep looking up, and remember, the universe is full of secrets waiting to be uncovered. Thanks for watching, and we'll see you in the next video.